children, now we are going to learn how to identify different nutrients in a food item. In our syllabus, we have got 4 tests. There are 4 food tests. Let's see. Test to identify foods. First one is simple sugar test, or we call that glucose test. Number 2, starch test. Number 3, protein test or biurate test. Number 4, lipid test. If you are in a classroom with me, I can get your active participation for the lesson. But at this moment, as you are not with me, I will have to do all these activities as teacher demonstrations only. But you have got a task to complete. First thing is you have to observe very carefully what the teacher is going to do, and after that you have to complete this table. Let's see the table. Look at the screen. There is a table. There are 4 columns in the table. In the first column, you have to write down the name of the food test. In the second column, you have to write down the materials required for the activity. What are the things, what are the materials required for the activity. In the third step, you have to write down the steps followed by the teacher when doing the activity, and finally you have to write down the observation. You have to record your observations in the last column. I think you are ready. Okay, let's start. First test is glucose or simple sugar test. Here are the materials required for the activity. We need a test tube, glucose solution, Benedict solution, water bath or a sprit lamp. At this moment, I am not using a water bath, I am using a sprit lamp. Right. We will see the steps of the activity. Method. Take 2 milliliters of glucose solution to a test tube and add 2 milliliters of Benedict solution to it. So, you see the volumes of glucose solution and the Benedict solution are equal. Then heat the test tube slowly or boil it in a water bath. Right. Now, I am going to do the activity. You have to record your observations. Firstly, I am going to explain you how I prepared the glucose solution. Here is glucose powder. Glucose powder is here. Right. Then I have well dissolved glucose powder in water. Right. Now, this is a glucose solution. This is a glucose solution. Now, you see it is a colorless solution. What is the color of the solution? Yes, it is colorless. It is colorless, right? Now, what I am going to do is take in a very little amount of glucose solution into a test tube in this way. I think you can observe. Yes, right? Now, there is glucose solution. Then, in this activity, I am going to use Benedict solution, Benedict's reagent. Then you can see it. What is the color of the solution? The color of the solution is blue. What is the color of the solution? The color of the solution is blue, right? Do you know this item? Do you know this apparatus? Yes, that is a dropper. Using a dropper, I can take a little amount of Benedict solution and it is added to the test tube in this way. Right. Now, I think you can observe the color of the mixture. The color of the mixture is blue. What is the color? Blue. Now, I am going to heat this solution using a sprit lamp. Okay children, now I am going to heat up the test tube using the split lamp. So, you have to observe the color change, actually there is a color change, you have to observe the color change while heating, right. Now, I am going to heat it. I am shaking the test tube well. Still the color is blue. You can check whether there is any difference in the color. I continue heating. You see I am shaking the test tube. It will take a little time. Yes, you can observe the blue color is gradually turning into which color? Yes, very good. The color is gradually turning into green. Then I continue heating. The green color is turning into yellow. Now the solution is yellow now. I am heating the test tube continuously. See what happens. What is the color of the solution now? It is orange. The heating is done continuously. The color of the solution is still orange. Okay children, now you can see we have got a brick red precipitation in the test tube. The observation is very clear, there is a brick red precipitation. Right. Now look at the screen. You can see the change of the color of the solution. Firstly you could see blue color, then it was converted to green, then yellow, then orange, and finally we got a brick red precipitation, right. So there is a conclusion in the activity. In each and every activity we can arrive at a conclusion. Our conclusion is glucose gives a brick red precipitation while heating with Benedict solution. What is the conclusion? Glucose gives a brick red precipitation while heating with Benedict solution. Now we have done the first activity. Now we are going to move on to the second one, that is the starch test. We want to check whether starch is present in a certain food item. Let us see. Now let us see what are the materials required for the activity. It is really simple. A piece of bread, iodine solution and a dropper. Right. You can observe this is the iodine solution, right, iodine solution. Now I am going to use another dropper to take a drop of iodine solution in this way. Right. Right. I have taken a drop of iodine and it is put onto the piece of bread in this way. Yes, the observation is very clear, I think. What can you observe? You can observe a purple blue color. What is your observation? Yes, you can observe a purple blue color. That was the method followed by me. Put a drop of iodine solution onto the piece of bread. Here I want to say you, instead of piece of bread, you may use boiled potatoes, boiled sweet potatoes, boiled manioc, right. That is the observation, purple blue color is visible. Finally, we can say that if any food item is given a purple blue color with iodine solution, definitely the food item contains starch. I think it is very clear. Now, we are going to move on to the third activity, that is for identifying proteins in a food item. Protein test, we call that biuret test, as we are using biuret reagent here. Let us see the materials required for the activity. A mixture of egg white and water, a test tube, then sodium hydroxide and copper sulphate solutions. You know, sodium hydroxide is a strong base which is widely used in the laboratory, and copper sulphate, it is a familiar solution, right. Now, I would like to explain you how I am going to do the activity. Put 2 milliliters of egg white and water mixture to the test tube. Then add a little amount of sodium hydroxide and copper sulphate solution to the test tube, right. There are 2 steps of the activity. Let us do that. Here you see an egg has 2 parts. One is egg white, the other one is egg yolk. In this activity, we are not using the egg yolk, we have to use the egg white only, right. I have taken a very little amount of egg white and it was well dissolved in water in this way. In my hand, I have got egg white and water mixture. This is an egg white and water mixture, right. Egg white is well dissolved in water and I have prepared a mixture, right. Now, we are going to move on to the second step, that is add a little amount of sodium hydroxide. Okay children, you can see this is sodium hydroxide. What is the color of the sodium hydroxide? Yes, it is colorless, no color. Right. Using a dropper, I am going to take a very little amount of sodium hydroxide. And it is put into the egg white mixture in this way, right. I will keep that aside for a while. Right, this is copper sulphate solution, right. It is indicated as copper sulphate here, copper sulphate. Right. Using another dropper, I am taking a little amount of copper sulphate . It is put into the test tube and I can shake well. You can observe a purple color is visible there. What is the color? Purple. The purple color is visible there. Then we can understand that proteins present in the egg white mixture, right. It proves that proteins present in the egg white mixture. Right. The solution turns to purple color to prove that protein is present in the mixture. I am sure that you are completing that table, then you can write the observation in your table. Now, I am going to move on to the last food test, that is the test to identify lipids. We need a food contains lipid and a white paper only, right. Okay. Now, we have done 3 tests, that is for identifying simple sugar or glucose, then to identify starch, then to identify proteins, and this is our last food test, that is lipid test. We need a food contains lipid and a white sheet of paper. Let us see the method of doing the activity. Yes, rub the food item contains lipid on the piece of paper, right? That is really simple. You can do this even at home. Okay, now we are going to do the lipid test to check whether a certain food item contains lipids. You see, I have got a white sheet of paper. I have got a white sheet of paper, nothing on the paper, right? Then I will take a little amount of butter and it is well rubbed on the white sheet of paper in this way. You can observe a translucent oily patch on the white sheet of paper. What can you observe? Yes, a translucent oily patch. If any food item is given a translucent oily patch while rubbing with a certain food item, the food item contains lipids. That is your conclusion of the activity. A translucent oily patch can be observed on the paper. Here I have given you a diagram. It is very simple. It is called as a translucent test. You can observe that there is a translucent spot of lipid and a spot of water is used here. Then we have used a sample of coconut oil and water. When we put a few drops of coconut oil onto the white sheet of paper, there is a translucent spot of lipid. But when we use water, when we put water, there is no translucent spot on the white sheet of paper. Right? It is simple, you can understand. Now we have discussed about different types of nutrients available in our diets and what are the functions performed by the nutrients and what are the nutritional deficiencies caused by the lack of nutrients. But we did not discuss about the balanced diet. What do you mean by a balanced diet? Let us see. A diet which contains essential nutrients and fiber in correct proportions is called as a balanced diet, right? Once again read with me. A diet which contains essential nutrients and fiber in correct proportions is called as a balanced diet. A diet which consists of a large amount of proteins is not a balanced diet. A diet which consists of large amount of carbohydrates is not a balanced diet. So, in a balanced diet, all the nutrients should be present in correct proportions as well as dietary fiber and water. Right. Now, I have done all the important parts of the unit now. I want to check whether you learnt what I taught you. So, I am going to assess your knowledge. For that, I have given you an assignment. Let us see the assignment. First question is, write 3 balanced diets for breakfast, lunch and dinner. Right, you have to think about suitable food items for a balanced diet, suitable for breakfast, lunch and dinner. You can write them in your writing book. In addition to that, you can paste some pictures. You can make a nice picture collection there. Number 2, what are the unfavorable conditions due to lack of balanced diet? When we are not taking a balanced diet, what will happen to our body? What are the problems to be faced, right? So, you have to write down the unfavorable conditions due to lack of balanced diet. My third question is, prepare a booklet on nutrient deficiency diseases. Right? I have discussed this with you. We have to face number of problems when we are not taking a balanced diet, right? One is nutrient deficiencies, right? Then you have to collect information from your adults, then from magazines, from books and from internet also. Okay children, the time has come to say you goodbye. I think today's lesson was really interesting for you. If you have any doubts regarding the lesson, you can discuss with your teacher and with your friends, as well as you can read your textbook at all. I hope to meet you with another interesting science lesson soon. Till that, be safe and goodbye.